Good evening, everyone. It is my great pleasure to welcome you all to this lecture series under Center for Contour Studies on Introduction to Contour and its architectural and planning approaches. This lecture aims to provide a platform for experts and practitioners to share their knowledge and experiences on introduction to contours and architectural and planning approaches. Through this virtual gathering, we hope to foster an interactive and informative dialogue that will inspire new ideas and insights. I would like to extend my welcome to all the students of ARA School of Architecture, Bangalore, and student of DC School of Architecture and Design, Vagaman, to the session. Please join me in welcoming our speaker, Architect Ganga Krishnan, a passionate landscape architect with 15 years of experience in ecological planning and design. She currently serves as a professor and head of department at Marian College of Architecture and Planning in Trivandrum. Architect Ganga Krishnan received her post-graduation degree from CEPT University in Ahmedabad and has been a vital contributor to the field of landscape architecture. She is also currently pursuing her research as part-time scholar in SRM University in Chennai. We are thrilled to have her here today and look forward to hearing her valuable insights on introduction to contours and its architectural and planning approaches. Please give a warm welcome to Architect Ganga Krishnan. Ma'am, I would like to welcome you.
Hope the screen is visible to you. Is the screen visible to you?
Yes, ma'am. It is visible. Yes, ma'am.
Okay. So, a very good evening to one and all who are present over here to understand or have an overlook about the contours, because only if I could meet you all in direct, we could have conducted a live workshop with a paper, pen, and digital mode. So it would have been more clear for you. But in this short time duration, I'll give you an overall introduction about what are the contours and how we have to approach a sloping site and what are the various methods and approaches while you design in a sloping site. This is just an overview about that. So let me start. Let us go into the first slide. So initially, a small definition about contour lines. Contour lines is a very familiar word to all of you. So contours are nothing. It's just imaginary lines which are drawn on a map for ease of our understanding. Drawn on a two-dimensional map connecting points of equal elevation. And it is actually mainly used to represent the shape of the terrain which we are dealing with, as well as to represent the elevation. So we are calling the spacing between the contour lines as the contour interval. So all these words will be familiar to you. So if anyone having any doubt in any slide, you can on to the microphone and you can give me queries, or you can post in the chat box also the queries. Okay. So in the image, you can see like a plan in two-dimensional layout, how the contours are shown. The mean sea level MSL had shown, and there are 10 meter contour intervals which are shown, and 10 meter, 20 meter, 30 meter, 40 meter, 50 meter, 58. So when you are getting a sloping site, you have to firstly understand that you have to read from either of one side, that is from top to bottom. If you're reading from top to bottom, you read all the things and do all the layers from top to, you have to study all the layers from top to bottom. That is from, if you are looking in from 58, that is the top elevation which you had shown in the figure. So you have to then read the contours from top itself. And if you are reading from 10, 20, 30, 40 like that, that is a lower level MSL 10 meter from MSL, it is 10 meter high, then it is 20 meter high, 30 meter high, 40 meters, and topmost portion is 58. Then you have to take the readings like from top, bottom to top, like that. So that will be more clear when I explain you about the slope analysis and all. So this is an elevation or the cross section of this contour. From this, we can have an understanding that lower one is 10 and it is rising up. So it is a mount. And if it was like vice versa, that is it's 10 meter, 20 meter, 30 meter, 40 meter, like 50 meter and 58, then it would have been a depression. So same representation will be there. The difference will be in contour intervals, the intervals. But what I had noticed is that most of the students, when they are getting a sloping side, they would have forgotten about marking the contour intervals. But the contour interval, marking the contour intervals on either side of the side boundary is very important. Then only we will get an easy read or easy understanding about reading the contours and understanding the design in a sloping side. So here you can see when the contours are far apart, then when here it is close, in the left hand side it is far apart, and here in the right hand side it is like closer together. So when the contours are coming closer together, that is here, then it indicates that the slopes are very steep. When here the distance between the contours is more compared to the other hand side. So here it indicates that contours are a bit more gradual. So this is for the this is a real-time picture which is shown on the right-hand side. Here we can see the contours. Here it is actually sloping towards this, and this, if we are imagining this as a contour interval of 60 meters or something, then how we have to read the two-dimensional picture. Here the 2D is actually superimposed on a sloping terrain. So how to read a sloping site, or how to understand a sloping site? We are familiar with the term slope analysis. Whenever you are getting a sloping site, you will be asking to do, or the first task is to do the slope analysis. But I will rather say, to understand a site or understand a sloping site, you have to undergo through various layers. To understand, you have to understand the layers of elevation or relief. Then you have to understand a basic understanding about the hydrology of the site, and there should be an understanding of the present land use of the site. Then about the vegetation existing on the site, and then vegetation as well as any structures existing on the site. Then aesthetical and visual aspects of the site. Then comes the slope analysis. Slope study will be complete only if we are completing all these layers and analyzing it. Then only the slope analysis will be, the picture of slope analysis will be complete. So firstly, let us see the relief map or elevation map in common. So here, actually the relief map, we can say it as a bird eye view of the entire region which we are taking into consideration. Here we will get a clear picture of which are the topmost portions, which are the lower portions. Is there any depression coming between the middle of the site or towards the boundaries of the site, etc. So we are actually.
I start now.
Hello. Shall I continue? Shall I continue? Is it okay for you to hear properly?
I would like to ask the students to mute your mic. All right, ma'am. Yeah, you can continue.
Okay. So in the relief map, usually we are actually, firstly, we'll have an understanding of what is the lower contour level. We have to mark which is the lowest contour level. We can say it as, suppose it is like 2 meters. And the topmost elevation is 50 meters. So you should actually have a division of this 48 meter difference. So from topmost contour is 50, and it may be, if in some cases 50 meter come here, or in some cases it is here. In this map it is here. Maybe topmost contour is here, and lowest contour is here. Suppose we are taking it as a 50 meter contour, and 2 meter contour is the lowest level. Then there is an elevation difference of 48 meters. 50 minus 2, that is a 48 meters level elevation difference is there. So for making the legend, firstly you have to make the legend. And for making the legend, you have to, based on the contour interval, whether it is 2 meters or 4 meters, you have to divide that 48 meters as per that. If it is 2 meters, then 24 legends will be required. And if it is like 4 meters, then only 12 legends will be required, like that. Or if it is 6 meters, only 8 contours or 8 legends will be required. Based on that contour intervals, you can actually group the contours also. And based on that 6 meter difference, you can create the legends. So the lower level will be, say it is 0 to 6. That will be like lighter, like it can be called as like beige color. Then the yellow, then higher elevations goes up, and the topmost contour interval, that is maybe ranging from 52 to 58. It can be like dark brown or black. This is the usual pattern of like giving legends. After creating the legends, you have to start doing the elevation map. Then you will get a clear picture of the site which you are dealing with. So this will give you a clear understanding of maximum and minimum heights in the site, and which are the higher elevations and depressions. So nowadays, there are a lot of softwares available using the platform of GIS. QGIS is a free platform, free software which you can deal with. Or then there is ArcGIS, it is a paid software. And there are, you can generate this elevation map using Google Earth, etc. So this is the usual images which you are creating from like elevation analysis using a DEM model in QGIS. And this is an analysis of slope gradient. So relief map or elevation map and slope gradient map or slope analysis is different, totally different. So what is meant by slope analysis? Let us see that. Slope analysis is actually, it can be generated nowadays, it can be generated using Grasshopper in Rhino 6 using Grasshopper plugin. And this is a generated map, but usually in the conventional method, we are doing the slope analysis in manual mode. While manually, in the relief map, we can see a clear gradation of colors ranging from the lower contour intervals towards the higher contour intervals. But in the slope analysis, it is actually dealing with the slopes in each contour interval based on the distances between the contours, based on the distance between the contours. So suppose in this, this is actually 6 meter or 30 meter contour, and this is 32. In the 30 meter contour interval itself, there are like shorter distance areas as well as wider areas. So here we had seen in the initial image, which I had shown to have a basic understanding of the contour, the spacing between the contour is more. So that means the slope is less. The slope is like comparatively it is flat or gently sloping. But whereas when we are moving towards this area, it is very close to each other, and that indicates that it is steeply sloping. So here also you have to actually have a basic, if you are doing it manually or in CAD, you can have a basic understanding about what are the maximum distances between the contours. Maximum distance here it is, so there will be like maximum distance, and you can have a range also, and this is the minimum distance. So say you can make a scale of your own, like 0 to 5 meter can be one slope. It can be ranging from 5%, because the slope also you have to calculate. I will tell you how to calculate the slope. So like that, a scale you have to prepare corresponding to each slope percentage or ratio of slope. Then only you can read the slope analysis map clearly. That indicates that this area is not suitable for construction unless modifications have made. And these areas are comparatively flatter, but it is a valley area. So how to deal with the valley areas, where to locate a playground, where to locate a building, and which all areas have to be make it as like a scenic elements, etc. You can decide upon the slope analysis after doing a detailed slope analysis. An example for a slope analysis map. Here it had given red color, like slopes greater than like 25% and over. Then 25 to 50%, given brown hatches. then gives 1:4 ratios, that is 12.5 to 25%. Like that, slopes are categorized. Then, before going into details of the slope analysis, how to calculate the gradient, etc., I'll give you a brief introduction about the drainage map also, because drainage and slope is closely associated, because based on the ups and downs on the site or region, the drainage flow will be there in the site. Because it is very important to understand the natural patterns of water surface drainage in a site. And we have to look into three primary concerns while dealing with the drainage map. Because first concern is like determining where the water is coming from. Because in maybe if your site is only this much area, the water would have been come from other sites also. So you should not, when considering a sloping site, you should not look only into your area of concern or area of interest. The nearby context is also very important while you deal with sloping site. So whether it is again going up, the slope is again going up, or in higher elevations nearby side, then the water will obviously flow. The natural pattern is like that. So water will obviously flow from the topmost areas to the lower area. So there will be automatically a natural drainage pattern which would have created long time back, because the weaker strata will get eroded fast, and that areas will be a path for the water to flow. And over a period of time, the water will again cut. When the velocity of water is more, it will cut the earth's the pathways or the flow ways, and the depth of that channel will be more. So here in this map, you can see that these are the major drainage ways. The black line indicates the boundary of that major line. This is the major carriageway of water, and from here and this towards this area and towards this, and all these are actually joining the mainstream. This is the mainstream, and these are the tributaries which carries water to the mainstream. So this indicates that this is a clear-cut valley. These are all valleys, but this is the major area where water traverses through the site. And where it needs to go, that is also where is the usual pattern of flow. And apart from that, you should have some decision making while dealing with the sloping side, that where the water should go. Are you planning to traverse it through a site as a water feature, or are you considering making it as a biosphere, or are you planning to like retain some water in your site, or are you planning like retain the water for some for a shorter duration in your site by giving a constructed wetland sort of ideas, thereby reducing the flow velocity. So the water will not reach towards the areas very rapidly. If the water, if a rainfall is coming, then the amount of water coming in a short duration or a short while will be the quantity of water will be very high. So the site may not be able to carry, as we are planning to construct some buildings or some other proposals in the site, there will be obviously impacts on the site. So we have to actually take consideration while doing the master plan that the impact of the water flow in our site should be less or it should be minimal. For that, we have to take consideration while planning how the water should flow through your site and where it should go and how it is traverses through the site. So the drainage is a very big concern while you do a master plan. And usually we call the waterways which water passes through as valleys, and there will be ridges on both sides of these valleys, because ridges are actually not easily, it will be hard strata, so the water cannot be easily cut through the ridges. The erosion will be happening through the weaker areas. So what is meant by ridges and valleys? It is actually a long, narrow, raised land formation with sloping side, especially the one side will be formed by the meeting of two faces of a mountain or of a mountain buttress or spur. Valleys, usually we can call it as a concave curve, that is an inward formation with sloping sides. This is actually a picture from movie. So here you can clearly see these are the areas where water usually passes through. And those areas are having some amount of vegetation also, apart from this grassland nature. So these are the ridges and these are the valleys in between. This is a major stream which traverses through the valleys which are traversing through this area or region. Here the topmost portions are ridges. This is a model made by students of CEPT. So this will give you a clear understanding of like what is that is here I could say that more about that your reading should be from either slope analysis. While you do slope analysis, your reading should be from top to bottom or from bottom to top. If you are doing the slope analysis by mixing like from in some regions you are considering slope analysis from top to bottom, and when it reaches here, if you are doing the slope analysis from bottom to top, then the distances will vary, then the perpendiculars will vary, then you will get a wrong slope analysis map. So while you're doing a slope analysis map, it is usually better to take slopes and slope analysis from considering from top to bottom. Here you can see valleys over here, these ridges, valleys, etc. And this is acting as a collection area or a depression where the water will get collected. Then comes the tool or the next layer, that is vegetation and land use map. Vegetation map mainly gives the concern about the ecological aspects of the site and how it is corresponding to the soils present in the site. So it is usually vegetation is an indicator of soil, presence of soil moisture in a site. Because when you read a site, when you take a walk along the site, you can understand that where the vegetation is more or the greenery is more, there is more amount of water. There is a groundwater table level will be high. So those areas are the usual patterns of water also. So the drainage, vegetation, slope, etc. all are interrelated. For the ease of understanding the site, we are actually termed it as vegetation map, drainage map, relief map, slope analysis, etc. So geological and climate characteristics, geological data, then climate characteristics, how much waterfall, how much rainfall it is receiving, then this water will get collected over this area. Might be it is getting collected in this place for some time and get flow. Then whether these areas are shaded, then the amount of solar radiation reaching that area, and based on the topography, that is slope, whether it is steeply sloped or whether it is gently sloping areas will be having more vegetation and more species diversity than the other areas. So vegetation, and why I had added the term ecosystem means vegetation. If there is sufficient vegetation, then there will be other organisms attached to that. Hope all of you know that, like you call usually when you do site planning then or site analysis, you will be familiar with the terms flora and fauna. So where there is flora, there will be obviously fauna. It may be an ant, it may be an insect, it may be a squirrel, or it may be an like a bird, or it may be some small jackal, or any other reptiles, rodents, etc. So these all are interconnected and closely associated to each other, and these are all are natural elements. So these natural resources, these will all come under the category of natural resources. So this is a vegetation map generated using Landsat images. And you can see, you would have studied in earlier in climatology classes like Leeward side, etc. So usually inside there will be more vegetation you could have experienced. So this is this is taken from the internet. Like it's a project which had shown each side, each area of the site, how they are dealt with based on the topography as well as the proposed land use. Vegetation is interconnect with the proposed land use also. What is proposed over that area? So based on that understanding, you can give a detailed analysis of what sort of vegetation will be gone over the what sort of protection to reduce the if intensity of sun's radiation, you can plan over the which all areas you have to make buffers, which all areas you have to utilize vegetation by strengthening vegetation and making it as a berm to screen the unwanted views. If you wish to screen the views from the side, because if it is a sloping side, there will be tremendous views flowing towards various portions of the site. So whether you want to discard some views, or whether you want to get some focal points, or whether you want to invite some views to site, these all can be possible through the playing of vegetation and landforms. Then comes the detailed portion of grading, which is after I have an understanding about about your site. After doing this detailed study of the site based on apart from this, if you are not like geologist or something like that, so I didn't deal much with the soil part. So after having a clear understanding about the relief map, slope map, hydrology map or drainage map, then vegetation, land use, and you will get a clear picture of what your site is. So you would have pointed out the site, what are the issues you had identified in the site, and while you collaborate the issues and an basic understanding of the site based on these natural features existing, the proposed use of the site, whether an institutional building is coming up on the site, or whether a hospitality project is coming up on the site, or whether a residence is coming up on the site, based on the proposed land use, the relationship between use factor and site factor, you have to analyze the site. The site analysis will be a combination of use factor as well as site factor. Whenever you analyze the sloping site, you should keep in mind both site factors and the proposed land use will be important. Then only you can analyze and understand. Based on that, you can start grading or develop a grading plan. Before going into a grading plan, we should have an understanding of what is meant by grading and what it is used. What is the purpose of that? When we comes into the topic grading, it is mainly landscape engineering. You are dealing with landscape engineering. So it is the process of modification of existing landform, and you can accommodate different structures, parking areas, play areas, circulation areas, and also ensuring the positive drainage in the site. And it requires actually a careful change of contours so that they support the integration of building with the site. Because obviously when a project is about to come in a site, there will be modification of site happens. So you have to obviously modify the contours or grade the contours, but it should be a careful process. Otherwise, there are chances of landslides, erosion, massive soil erosion, etc., flooding, etc. So this is actually after doing the grading, you will be getting a desired effect what you want. If you had been to IIM Bangalore and all, you would have experienced that amphitheater, views of the amphitheater. It is actually placed in a slope. Utilize the slope to place the seating. And what are the 3 principal goals while developing a grading plan? So main aim of that developing grading plan is to keep unwanted water from entering a building, restrict the water entry to a building, then keep the surface runoff from creating damage to property or people during periods of heavy rainfall as well as subsequent runoff. So you have to properly give drainage ways to drain the water away from your property or useful areas. And you can think about various plans, whether you have to harvest the water, whether you have to use it as a feature in your site, etc., or whether you can make it as a seasonal or temporal variations in the site. That is according to our designer's viewpoints or considerations. Then to accommodate the structure on the site with disturbing the site to a minimum. That is minimum disturbance to the site. That should be a motto while designer approaches a sloping site. But in contradiction, we are experiencing mainly in Kerala that every sloping site is getting chopped off, and it is like an cake, icing, when a cake has got finished from a base, it is looking like that. Every side will be looking seems similar, and buildings are constructing on that. And behind that building, there will be a huge cliff sort of experience. The slopes are not utilized properly. So this is an example of a grading plan. Here you can see the grading. Actually, existing contours is a dotted lines, and these are actually the modified contours. So usually, a landscape architect usually represents the modified contours in a different color or as a continuous line. And here also you can see the contours are modified. Contour is modified like that based on the desired effects you want to achieve in the site. Maybe for this building to happen, this building, its contours are modified. While modifying the contours, you have to understand that if your building footprint is like this, if your building footprint is like this, you should have a clear space around the building. Unless you are constructing a retaining wall. If there is a retaining wall in this area, in the lower level, you can't give a maneuvering space around the building. But because building wall itself may be acting as a retaining wall. But in this side, suppose if it is sloping towards the lower areas, and if there is sufficient open space which you can provide, then give some space on the sides of the buildings where it can be accessed. Because so that you can either people can move towards this side to have a maintenance or any other purpose, as well as they can actually open the windows, or they can develop the spaces, spacious, etc. So most of the times when students design in academic exercises, they will give like slope. They'll give the building footprint like this, but they don't have a thought about the open space surrounding the building. So while you're designing a building in a sloping side, you should always have a thought process that like from the building and to the building, towards the building, as well as from inside the building or from the building towards the exterior. That thought process should develop. And for that, while developing a sloping side or while designing a sloping side, developing the sections and solving the slopes simultaneously is a mandatory process. Unlike in other studios where you have dealt with flat side, in these projects, if you are dealing with a sloping sloping side, you have to simultaneously work out your detailed sections, side sections and building sections. Then what is meant by grading, how it is expressed, etc. That is, it refers to the changing elevation along the Earth's surface or the rate of the slope, usually expressed in percentage or ratios. And or degrees, it will express only in the case of like a large scale project or regional scale project. Usually we express gradients in percentage or ratio. So 1% slope indicates that the ratio is 100:1. And 10% is 10:1 at 6 degrees. And coming to the G, you can see here that is G. G represents the gradient, and D is the vertical rise between that is the contour interval. If the contour interval is 2 meters, then D is 2 meters. And L is the horizontal distance between two. If this is a contour line and this is a contour line, the horizontal distance between these two contour lines is L. So to get the gradient, we can use like D by L into formula, D by equation, D by L into 100, and it will be expressed in percentage of slope. So here that's shown in feet actually. 4 feet is the vertical rise, that is 1.2 meter approximately. And here you can see that is you can use for intensive activity because it is comparatively flatter in appearance. And here it is 4 to 10% of slope. So there you can give an informal activities. You can plan some informal activities. And if it is above 10%, then the activity should be limited. You can use for landscaping or any other uses. And if it is slope is steeply sloped, that is over 50%, it is susceptible to erosion. Then that slope have to be protected, and it can be planted with some grass species, mainly vetiver sort of species. Vetiver grass, in Malayalam, it is called as Ramacham. If it is like 3 feet high above the ground, it will go like 10 feet depth deep. Its roots will be 10 feet deep. So it is actually a binder, soil binder. In Kongan areas and all, on the other sides of the railway lines, it had widely planted to stabilize the slopes. So these are the actually broader classification of slope percentage, like what should be the maximum percentage and minimum percentage, and the preferred percentage for each areas, each function, like driveways, parking areas, what should be the maximum, minimum, and preferred, and slopes of shoulders or streets, sides, driveways, etc. What should be the preferred slope percentage? Then walks, lawn areas, and for roads, driveways, it is given as like 1:10 ratio. But if you can give the slope in 1:12 slope, that is a desired ratio of slope while you give the roads and driveways in a sloping side. Then the road has a grading for streets. While what are the considerations to be given while grade the streets and roads? The road has a constant slope and that it presents more problem. So function of the road is to serve as a path for vehicles, and always it will take care of the drainage system also. So a road, while you design a road in a sloping side, it should be in such a way that it has to be minimize the fluctuation across variable terrain, and it should maintain a constant slope for gradient, and you have to provide the shortest route as possible, and think about minimizing the cut and fill in the site while developing the roads as far as possible parallel to the contour lines, because while if the slope is steep and if we are not following the contour lines, then there will be a lot of cut and fill will be happening in the site, and it will actually create an imbalance, massive imbalance on the site. So if you are designing a resort building or resort project in a sloping site, if you are giving a road on the middle side and cottages you can arrange in both sides of the road, so you can actually reduce the impact of roads on the site by maintaining like that. One side the cottages will be in a bit elevated areas, and other side it will be flat or it will be like generally sloping downwards, but the same road can serve the buildings on either side. I told an example of resort building. It can be in any case, if you are planning the buildings on either side of the road and achieving the levels by on one side the terrace can be accessed like that, then those sort of design considerations, if you are planning while developing in a sloping site, it will be helpful to minimize the impacts on the sloping site. So this is an example of a proposed grade maintained for developing a road. This is the road, and how to take care of the drainage along the side of the road. And here it is constructed as a berming on the center or mound on the center of the either side of the road, and it is sloping towards one area, and here also from the road edge also it is sloping and it is creating a swale, and the swale is actually carrying the water. Instead of we can call the gray infrastructure. Gray infrastructure is the constructed infrastructure, that is constructed drainage, etc. But this is actually can be sort of green infrastructure by giving the sloped grass base. The water is getting collected on the drainage swale, and it gives visually pleasing outlooks to the people who are driving through the areas, instead of creating a monotonous appearance, which is of a major concern when our highways are getting developed. This is another view. Here the water is like through the infiltration. The pipes are getting collecting the water after like filtered water is getting collected through these pipeways, and the water is carried to some collection areas. So this water can be used. Nowadays, a lot of water is getting wasted because the water is not potable. Even though a lot of rain is there is like drought is there. So there is severe shortage of drinking water or potable water in the there is a severe shortage of water existing in this area. Then there is also another thing is happening, that is grading around a building. Grading around a building, when we consider, that is, do you have any doubts regarding these, any topics? If you have any doubts, you can clear and you can go to another slide. Does anyone have any doubts?
No, ma'am.
Okay, so I'll continue. So this is actually, while you design a building or site a building in a sloping side, then the driveway is sloping, and you should be taken care of a proper drainage way. Should be proper, a drainage way should be properly considered, because water should flow away from the building, as well as the water from the slope should not reach this area. So there should be a proper drainage towards this area. Usually when you experience the parking in the basement of commercial buildings or shopping complexes, you would have seen a drainage coming before entering into the basement parking area. So that is it, to protect the water to overflow into the, prevent the water flow into the interiors of the building. So that should be taken care of properly. So usually when I had I design, usually gives like a drainage way, drainage channel before entering into the ramp, and before entering into the ramp, and ramp get reached also, there will be a drainage will be given. Otherwise, the amount of water which is flowing towards the slope, we cannot control. It might overflow into the building interiors. So there are like design considerations. What all design considerations should be given on sloping site? So major concern is like a design building on sloping site. The major concern is what type of foundation we can give and how deep it could be It could go, because usually on sloping site when we give, the foundation will be more deeper. So how to screen that view of that foundation, how to stabilize the slope, that is a major concern. So in that cases, we have to take consultants, mainly the structural consultants, they will help. So the basic understanding of how the building should be sited, you should have, and they will give the assistance of like foundation, what type of foundation, how deep it should go, what should be the retaining wall thickness, etc. Then another concern is like accessibility. How to access is the higher level. So the levels you have to utilize. If you are entering from the road is from this area, then how in the sloping side it will be like going downwards. So this will be a viewing area or the living space. So that sort of planning, how to design in a level, in a sloping side, you have to think about, instead of normal notions from coming into a ground floor, then approaching the top floor. It might change. There will be variations in our thought process, and you have to deal that spaces carefully. Then only the desired effects you will be getting in a sloping site. Otherwise, it would have been a trauma also. So that sort of detailing in sections, you have to think about sections and views, etc. Then you have to be careful about how to create panoramic vistas from your site. Whether you should screen some views, whether you should open up some views, what sort of skin of the building facades you should give, or outer skin, how you have to develop, whether you have to screen the wind, because the wind velocity will be more when it is exposed to slopes. So whether you have to screen or whether you have to tunnel it, a lot of considerations you have to give while you're dealing with a building in a sloping site. When water comes, how to deal that water. It should not damage the building. So how to take care of that aspect. Then another important aspect is lighting and ventilation. Major problem when you deal with a sloping site is lighting. How to expose the building into expose the sides of the building. If the retaining water is coming in this area is not getting proper. So whether how to make sure that the light is entering from the sides or the tops, what are the other possibilities, etc., that have to be taken care of while designing. And ventilation is also another important concern, how to provide ventilation throughout the building. These are some examples which I have taken from internet. How buildings are beautifully sited along with the topography, sloping topography, instead of like cutting and placing. This is actually merging. Then this is Katalama beach hotel of renowned architect Jeffrey Bawa. Jeffrey Bawa, he actually utilized the slopes and provided spaces according to that. So it is building is not jutting out. Usually architects or designers are having the notion that building, or clients are having the notion that building should project it out. But buildings are actually, we are constructing the building on the natural fabric. So it should not be like stand allowed, or in some cases it has to, but in most of the cases, it can actually be a part of the nature or the setting it is being. So that sort of concept beautifully portrayed by Jeffrey Bawa through his buildings. And here comes the significance of master planning. So what is master planning? Why it is more significant? While you deal with an architectural project, there is a lot of talks or a lot of discussions happens about the planning of a site or master plan. So usually it gives the connection between building as well as social settings and their surrounding environments. So it includes analysis, recommendations, and proposals for a site's population, maybe future population which will be using that site, economic aspects, housing aspects, transportation aspects, community facility, neighborhood, proposed land use, etc. So landscape architect usually create detailed plans indicating the modified topography, then vegetation, probability of vegetation, what type of vegetation, where it should come, how it should look like, then walkways and other details of the landscaping, then stormwater drainage, integrate art and cultural elements, etc. Then the modified plan the output is actually a comprehensive land development plan, which outlines the site with suitable location for the proposed architectural project. So comprehensive land development plan will be having the grades, how the grading has to be done, where the roads should be laid out, where the buildings can be sited, which are the possible ways of drainage areas, etc. This will cover up in the comprehensive land development plan, and where the retaining wall should come up, and where the land can be stabilized with the natural slopes or planting, etc. So the road layout based on land suitability can be worked out simultaneously with the siting of building, and it should give minimum disturbance to the steep slopes. So these are the examples of which are taken from Ayan Makkar site. This is actually a resort project, also sourced from internet. Here the cottages are placed along the sloping side, and it is actually on the either side of the road it had given. So it is given minimum disturbance to the sloping side. Then there is a waterway going along through this, and how the sloping site is utilized for creating a panoramic view from the cottages as well as the siting along the slopes. This is another master planning project. So this is the end of the presentation. So I'm taking the words of the Ayan Makkar, that is a renowned landscape architect who is known as father of GIS and founder of environmental planning and author of the famous book Design with the Nature. So he told that the shaping of land for human use ought to be based on an understanding of natural process. Let us give the earth, restore the earth, and heal the earth. Thank you all. This is coming to the end of the presentation. So if you have any queries or doubts, you can ask me.
Now we will be having a discussion session. This will be an opportunity for you to engage with the material and clarify any doubts you may have. To submit your queries or questions, you can either unmute your mic and ask, or you can use the chat box provided, students. Ma'am, I would like to start with a question. So, ma'am, as we discussed that nowadays the contours are cutting down like ice cake is what we discussed. So, where are we seeing a future of contours in architecture? So, how might it will be evolved with the aspect of the over time changing needs and preferences of people? How would be the future of contours in architecture?
Actually, that should be come from our responsible architects only, because architects should have that basic understanding that we should plan according to the land topography or land form. That sort of understanding should be there. We should not go for like easy way out. So how to play with the topography, how to deal with that sloping side. So there should be a proper teamwork and synthesis of like planning should come in the initial stages itself. Usually landscape architects will be called the like final just to like what you said, like ice the cake. So that should not happen. It should be a thorough discussions and planning should go from the initial stages itself, and the site should be modifications can be made. Any sort of desired effect can be bring out, but that sort of considerations should come, and we should actually involve that importance in each architectural studio from first year onwards. It's a social responsibility. Not only architects, there are a lot other design streams also. So in the planning level also, it should be ensured, because in other countries and all, for each project to be approved, the landscape architect have to be like involved, and landscape architect have to give a detailed proposal with the proper levels which has to be maintained, and it should be like as we are getting sanction plans that also should get approved. That sort of approaches should actually implemented in our state as well as in our country also.
All right.
I hope I had answered.
Yes, ma'am. Yes, ma'am. Thank you. Students, do we have any more questions?
Hello.
Nobody is asking any question. Nobody is having any queries.
Ma'am, I had found a question before. A question from Kirutik Raj. Kirutik Raj, he was asking, how do we find the ratio of slopes? What's this question?
That is expressed in percentage, no?
Yes,
that
ma'am.
one shown expressed in ratio. You can slide. I have to go to the slide. I think the vertical, what you had shown, like the vertical distance in a triangle. What if you are remembering? If you are taking the vertical distance as 1 meter and the horizontal distance as 12 meter, then the ratio will be 1 in 12. Or it is 1 in horizontal distance is 4 in a triangle, and the vertical distance is like 2, then the ratio is 1:2.
All right, ma'am. I hope ma'am has answered your question, Kirutik Raj. Any more questions, queries from the students? You can drop your questions into the drop box. All right, ma'am. Uh, I would like to express my gratitude and sincere thanks to our distinguished speaker, Architect Ganga Krishnan, for generously sharing her time and expertise. Your contribution to this seminar are invaluable and undoubtedly enhanced our understanding of the topic, ma'am. I would also like to extend my appreciation to all the attendees. Almost we have 160 registration and overall 60 participants. Your participation and engagement is a success of the seminar. Thank you for actively participating in the session. Once again, I extend my sincere thanks to everyone. Thank you, ma'am.
I had shared my email ID in the chat box. If anyone have any queries, if you want to contact me further, you can actually mail me. I can help you in case you're dealing with some projects or something.
All right, ma'am. Thank you, ma'am.